Hi, I'm Yaoyang Ji. In this video, I'm going to talk about quantum dot LED. So, quantum dot LED can improve the performance of display. I will going to talk about the current display technology, their advantage and the limitations. And I will also go over how can quantum dot improve the display technology, what is quantum dot, and its challenges. Nowadays, display is everywhere. Your phone, your laptop, TV, cars, and so on. How does it work? Actually, a display shows a digital image made by many small pixels, and each pixel has three colors: red, green, and blue. We know that they are primary color, so in principle, each pixel can show any color we want. And since human eye cannot resolve such a small pixel, so we see a smooth image on display. Go to quantum dot LED. I would like to first talk about two most popular display technologies, LED and OLED. LED stands for light emitted diode, and OLED stands for organic light emitted diode. Without going into very details of their working principle, I want to show you the basic structure and basic working idea of them. On your left side is LED. Basically, we have a light source coming from the LED back panel, and you'll notice that in this structure we have two polarizer which are perpendicular to each other. Without the liquid crystal, the light cannot just go through the screen. So by adding a liquid crystal, we know that it can change the direction of light polarization, and we can use the applied voltage to adjust amount of light go through this structure. So the liquid crystal here is just like a switch. It can control the amount of light for each colors are red, green, and blue, so that we can mix any color we want. On your right hand is OLED. You can see the structure is much simpler. Basically, in the middle we just have organic emitters, and the organic emitters are organic materials basically, and by applying voltage, it can emit light with different color. In other words, in different wavelengths. LED is a good technology, of course. It got a very large market since it has been developed for many years. It's mature technology. The price of it is very affordable, and it also has a long lifespan. But it also comes with many disadvantages. Firstly, it has low contrast ratio. The contrast ratio means the brightest part and the darkest part on your screen. It is because the physical property of liquid crystal, it cannot turn off or turn on, or in other words, polarize all the light in 90 degrees. So therefore, there is always light coming from each pixel. The screen will not produce a real black color. Secondly, it has high power consumption. We have a big LED back panel that is on all the time, and it may also get the light leakage. Thusly, it got limited range of colors. OLED use completely different technology from LED. It got many advantages. Firstly, it has very high contrast ratio since it doesn't have liquid crystal inside, so it can fully turn off the light. Secondly, it got relative low power consumption, and lastly, it has very high color gamut. But it also comes with many limitations because it uses organic material inside. Since the lifespan of organic material is relatively short, so it may cause a burning issue. The burning issue means it will leave a shadow or some bad area on your screen. And it also has limited brightness because if the OLEDs is very bright. The lifespan of organic material will be very, very short. So the manufacturer just limit the brightness of OLED. Lastly, it's more expensive than LED. Okay, after talk about basic idea of LED and OLED, we know that they actually have a lot of limitations. So scientists and engineers trying to use a nanotechnology called quantum dot to improve the performance of display. Quantum dots are actually semiconductor particles with a few nanometer in size. And scientists find that if we shine blue light to quantum dot, it will actually emit light with great intensity and a narrow spectrum. Interesting thing is, even we have a same quantum dot, but if we vary the size of it, it will actually generate light with different wavelengths. In other words, different quantum dot with different size will give us different color. And the color is very pure since the spectrum of the light is narrow. Then by just putting the quantum dot will give us red, green, and blue light to a thin film, we can generate a light source with high quality. Right here is a basic structure of quantum dot LED. We can see it's basically a LED, but the back source is changed from the regular white LED to a blue LED with a quantum dot film. So as you can see here, the left hand side is a spectrum of regular LED, and then the right hand side is the spectrum of quantum dot, light emitted by quantum dot. We notice that the spectrum for each color is very narrow, so therefore we can generate more colored and with higher accuracy. So it basically improves the color purity greatly, and it also improves the range of color. Also, it did not solve the LED's problem, that is, it has relative low contrast ratio, but they indeed improve the image quality by a great amount. So quantum dot, what is quantum dot and how does it work? Without going to very deep quantum mechanics, chemistry, and math, I want to give you a general idea of quantum dot. So quantum dot are semiconductor particles with a few nanometer in size. So the structure is like the low energy domain is surrounded in all three dimensions by high energy region. And the band structure can be modified by changing the size. It may make you think about a model that we learned in class, which is particle in box. That's right. We can describe this model, the quantum dot, by particle in box, and we all know that the equation, the energy level, can be described in this equation. And by looking at that equation, we notice that indeed, by changing the size of box, that is L, we can change the energy level. That is, we can modify the band structure. As you can see at on bottom right, if we have a large quantum dot, then the energy level is relatively short, so that electron drop from high energy level to low energy level will generate small energy and corresponding to long wavelength. That will give us red color. And if you look at the small quantum dot, which painting blue, you will notice that the energy difference is large, so that the electron drop from the high energy level to low energy level. It may generate a light with higher energy, and which corresponding to shorter wavelength that will give us blue light. Here is a brief history of quantum dot LEDs, basically evolution from research to commercialized products. In 1980s, quantum dot was proposed and first fabricated by those three gentlemen who eventually won the Nobel Prize in Physics in 2016. And in next 10 decades, more and more people are trying to investigate quantum dots. Basically, they try to build a more solid understanding to working principle of quantum dot and a more mature fabrication technology. Then in early 2000s, people start to think maybe we can use quantum dot to improve the performance of display. So in 2013, the idea that quantum dot enhancement film comes up. That is what I showed in last slide. Then 4 years later, 2017, Samsung comes to their first commercialized quantum dot LED, what they call QLED. Current state of art is quantum dot OLED from Samsung. On the left is OLED structure as we discussed before, and on the right is quantum dot OLED. Basically, they use organic emitters to shine the blue light to the quantum dot film, and the quantum dot film can convert blue color to red and green. So this quantum dot film actually improves the image quality from OLED. They improve the color purity and has wide range of color. It also solves the intense brightness problem from OLED. Quantum dot enhanced displays still have a lot of challenges. Firstly, quantum dot LED has a lot of inherent drawbacks of LED technology. As we discussed before, quantum dot LED still have liquid crystal inside, so that it cannot achieve very high contrast ratio. The degradation of quantum dots over time can significantly impact the longevity and performance of QLED displays for sure. Quantum dot LED can be also relatively expensive compared to some other display technology, such as LED, because it needs a quantum dot layer, so it will have extra cost and a more complex fabrication technique. Even for our state-of-art quantum dot OLED, since it has organic material inside, so the lifetime problem is inevitable. This is the end of the video. If you are interested into this quantum dot displays technology, you are welcome to discuss with me. Thank you.